Linear regression with engineering applications. So what is linear regression? Well, linear regression in simple terms is applying or fitting a linear equation to an observed scatter plot of data. In other words, it's taking a scatter plot and applying a linear line to it. The equation for the line is as follows: y equals beta naught plus beta 1x. In layman terms, it's basically just y equals mx plus b, as simple as I can put it. And when you're applying a linear regression, it uses a method or model for fitting, usually known as principle of least squares, which is that equation I just showed above you. And linear regression requires a foundation, and that foundation is scatter plot. Like I mentioned, you need XY data points plotted out on a graph in order to apply a linear regression line. Once you do that, you should get something like this. Now, the one on the left is an example of what would be a good linear regression model, and the one on the right is the example of a bad one, and I'll explain why in the next slide. So what does it mean? To determine if a linear regression model is a good fit, you will calculate the coefficient of determination. Now, what that is a formula, which is r squared equals 1 minus SSE over SST, and SSE is the error sum of squares, and SST is the total sum of squares. And like I mentioned in the previous slide, the one on the left was good, the one on the right was bad. What I mean by that is that the one on the left was a good fit for a linear regression model because it has a high r squared value, whereas the one on the right has a low r squared value, which means it's probably not a good fit, and you should probably find a different model to actually use as a fit for your data points. Now, to the next slide. Now, this slide is just an example of a linear regression in place. It's basically checking h-index with number of citations on papers being used. In other words, how many times is this paper cited based off its h-index, and looking for the correlation between that x and that y variable, which is what you can see from the picture. This is a very good article. I highly recommend reading it. Good information on it. Now, there are other forms of linear regression, multiple linear regression and nonlinear regression, and I'm only going to touch up on multiple linear regression, which is basically just linear regression in its own way. So basically, multiple linear regression is checking multiple types of x variables and seeing how it correlates with the y variable, basically same as linear regression. As you can see from the picture, it shows you the same formula, just with extra betas and x values. So here I have an engineering application of what it is. If you really want good details on this application, I would go and read it. It's a lot of material. I don't want to condense it all into this PowerPoint because it'd just be way too much. But basically, it's checking the heat load on rooms. So in other words, it's the temperature of rooms and the heat load and AC load requirements on an AC unit. And what they use is a multiple linear regression model to determine all of these graphs. With multiple variables. If I remember correctly, it's up to 6 variables that are checked. It's a very good article, but yeah, that is basically linear regression with slight engineering applications.